And at the end of the input string, if the current state on which automata is there, if it is from the one of the final states, we declare the given input as an accepted. So how does Turing machine differs? Turing machine basically performs three different tasks in the place of just moving to right by oneself. But it does it. It changes the state as we do in case of finite automata. It moves the tape head to left as or right by oneself, and it replaces the current symbol. That means whatever symbol is being available on the tape, like for example here at the beginning 0 is there. What machine will do is it will simply scan the input. It will change the state. Whatever symbol is available, it would be replaced by some other symbol or maybe the same symbol. 0 will be replaced by 0. We'll say that the symbol is not altered here, rather the symbol is skipped. Or it will replace symbol 0 with some other symbol. That some other symbol is nothing but the symbol which belongs to the alphabet tau, which is nothing but set of allowable tape symbols for Turing machine. And replaces the current symbol, tape head mode to the right and changes the state. These are the three operations which are performed by a Turing machine on the scanning of any current input. The tuple definition of Turing machine can be given as given here. It is defined by 7 tuple q summation tau delta q0 bf, where q is finite set of states, summation is referred as a finite set of input alphabets, tau is a finite set of allowable tape symbol, q0 termed as the initial state, capital B termed as a special tape symbol referred as a blank, and capital F is nothing but the finite set of final states. This delta has a mapping which can be given like this. Del of say qy is the initial state, and let's say xi is any input symbol which is currently being scanned. What it does it changes the state, let's say to qj. It replaces this xi with another symbol, let's say yj, and movement of the tape head also happen, which also need to be specified specifically here while showing the transition function. Let's say refer it as a m. Okay, where this qi and qj belongs to capital Q, this xi belongs to summation, yj belongs to tau, this mj is basically either L or R. Okay, so the mapping for delta in case of Turing machine is given as Q cross summation gives this capital Q, because Qj also belongs to capital Q, Q cross tau cross moment either to the left or to the right. So basically, if you want to specify that from state Q0 on the input of 0, the state change is q1 comma input 1 replaced with let's say x and movement to r. It can be visualized like this. It can be written like this. Del of q0 comma 0 gives q1 comma x comma r. And if we want to write transition diagram for this, it can be written like this. q0, next state is q1, where the symbol scanned is 0. This symbol scanned is replaced with another symbol x, and movement of tape head is to right. So this is the way in which transition diagram is represented for a transition function which is given like this. Okay. So any query up to this point, that how does Turing machine works? That is specified here. What is the tuple definition for Turing machine, and how the transition function for a Turing machine can be written in terms of function or in terms of diagram. If you have any query up to this point, please let me know. If you do not have query, we'll go with this example, our first example for Turing machine. Yes, any queries to anybody?
No, sir, we can continue.
Okay, great. Now let's take very simple example I have taken here, that design a Turing machine to multiply a binary number by 2. Now whenever we have a binary number and we want to multiply it by 2, it can be very well achieved with the help of suffixing a 0 in front of that binary number. Okay. Now when we say we have a binary number, it is but natural that the binary number has binary number comprised of two alphabet, two symbols. Our summation would be what? 0, 1, right? Either it would be 0 or it would be 1. And our input can be represented by any such combination. One more thing, that we assume that we have a special tape symbol called as blank in Turing machine tape, and which is preceded as well as succeeded by the working area of a tape. That means we assume here that our Turing machine's working area, if at all available, it will contain the input symbols, and beyond input symbol, the tape will have all blank symbols. Okay. So what we will do, let's say we have input like this 1, 1, 1. Okay. So would be at the beginning, we will be at the leftmost place on the input, right? Like this. Say this is our tape. We have 1, 1, and 1 as an input, which means this input is preceded by blank and succeeded by blank. And at the beginning of working, our tape head is pointing to the leftmost symbol in the given input. So that is what we are assumptions. But what we'll do is we just need to suffix a 0 after this input. So basically what is needed is this blank 0. This blank is to be replaced with 0. That's all. This is nothing but the binary equivalent of a number which is multiplied by 2. So what exactly we are doing here when we are doing this? At the beginning, we are at the leftmost cell. So we will scan this input one after another. 1, 1, 1. All these inputs will be scanned. Basically, what does it mean? The current input symbol will be replaced by the same symbol. And as soon as we receive this blank, which is on the right hand side, which indicate that your input is over, this blank will replace with 0. That's a simple task. Let's see how it can be shown, or how a Turing machine can be designed for this. It is but natural. We are beginning with Q0 as the initial state. In Q0, we will get first symbol as a 1, right? Or 0. It may be any symbol. Whatever may be the symbol, what we need to do is we need to replace the symbol with the same symbol. That is, if 0 available, replace 0 with 0, move to right. Similarly, if the symbol is 1, replace 1 with 1 and move to right, because we are not changing the given input. We are keeping the given input as it is. We simply want to introduce the 0 after the given input. Now, how to know whether this input is or? But natural, it would be indicated by this blank, right? So as soon as we receive blank symbol on the right hand side, that blank would be replaced with 0 and movement to right. Is this clear? Since we have already scanned our input, whatever next blank we are getting, whenever we are getting a first blank, we'll simply replace that blank with 0, movement to right, and this would be our final state. Is this clear?
Yes, sir.
Yes, it's clear.
Good. Now, tuple definition, what capital Q will consist of Q0 and Qf, two states. Your alphabet, input alphabet will comprise of the first symbol in this sequence, 1, comma, colon, 1, comma, R. Out of that first symbol, that is 1, 0, blank. Okay. Blank, we may not write in inputs alphabet because we are considering it separately as a special symbol on the tape. So we can write simply 0 and 1 as a summation. Tau is what? Tau is basically set of allowable tape symbol which can be replaced. So this middle symbol, whichever symbols we use in the middle, those all will nothing but the set comprising or consisting, which is represented by tau. So our tau here would be 0, 1 and back. Delta is a transition function whose mapping is this. This whole thing is mapping, which is represented in the diagram like this. Delta is this whole thing. This whole thing is delta. Next is what? Q0, it's an initial state. Capital B is a special tape symbol referred as a blank symbol. And capital F is nothing but just one state we have as a capital F, which is nothing but QF. So this is your first example. Okay. Any queries about this?
Sir, can you explain the mapping of this question? Means basically I want to ask the delta, how
Delta
we will
mapping.
write
Okay, fine.
when we are making this transition diagram.
Mhm.
So while giving the delta in tuple, so do we have to draw the diagram there or we have to give a mapping? So I want to know that mapping.
Uh, Basically, what is the table? Table is nothing but the tabular representation of this delta function written in terms of tabular form. That's all. Basically, what we are trying to show here is how our Turing machine works. That we represented already here in terms of delta, right? So
Yes, sir.
this itself is your transition function mapping. Correct. This itself is your transition function whose mapping is this. If you see here, we are having initial state here. From initial state, we are applying some input like here 1 or 0, which is being replaced with a replacement symbol and moment is shown to right. That is what has been reflected here in terms of transition mapping. If you see from a initial state which belongs to capital Q on the input which is from summation, what we get is a next state as a resultant, which is also from capital Q because it is part of capital Q cross, right? Capital Q cross. Now what we are doing? We are representing replacement symbol here, which is from tau. So this is
Yes.
your replacement symbol, right?
Yes, sir.
Cross moment either to the left or to right. So L comma R. This is the final thing. Okay.
Okay,
So
sir.
this is
Okay, sir.
transition mapping. I hope transition mapping is clear.
Yes, sir.
Let's go for second example. Now what does it say? Model a Turing machine to recognize the language L equals to 0 raised to power twice n, where n is greater than or equal to 0. So if we try to write a set for this, let's say S be a set, what will be the set of strings which would be belonging to this language? It says 0 raised to power twice n. Now 0 here represented in terms of a unary number, right? Wherein the number of zeros would be in the multiple of 2, where n ranging from range has a range of values ranging from 0 and greater than 0, right? N greater than or equal to 0. So basically what does it means? When n equals to 0, you have epsilon, right? Belonging to language. Yes or no? Epsilon. If your n is equals to 1, we have two zeros. If n equals to 4, you have four zeros. N equals to 6, we have six zeros, and so on. So this type of language should be accepted. Basically, we are talking about even number of zeros should be accepted by a Turing machine. Okay. So every time we need to check, do we have two zeros followed by two zeros or followed by two zeros and so on, right? So basically, if we talk in terms of a tape and your value of n is equals to 6, it means your input is like this. Your input is like this: B, 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 1, 2, 3, 4, 5, 6, 6 B's are available. We are beginning with this point and moving towards right. Every time we need to ensure that we have even number of zeros.
Sir,
So
if n equals 6, then would it not be 12 zeros? Because
yeah,
there's two.
I'm talking about value of n, wherein this love we'll have n equals to this, that means we'll have 12 number of zeros, right? The
Okay.
example which I have taken here is of n equals to 3, right? 3 zeros, basically 3 times multiplied by 2, that is 6 number of zeros are available. So even number of zeros we need to check. So basically we are here, we require to check the pair of zeros. Does pair of zero exist? If zero doesn't exist in pair, if we found any zero which is not in pair, we should declare that the language doesn't belongs to the given category, right? Given description. So also proceed for that. We'll simply have a loop like this. Say Q0. If it is first zero, replace it with zero, move to right. Q1. For second zero, again zero, replace with zero, move to right. So in this way, we'll continue with our loop. And at the end, we must get blank, which is representation of end of input. If that blank is available in Q0, only in that case we'll move to final state, right? If we get blank here, it means we do not have twice n number of zeros. Rather, we have twice n plus 1 number of zeros. So this is your Turing machine for modeling language L, where 0 raised to power twice n greater than or equal to 0. Okay. Should I proceed for the next example?
Yes, sir.
Next example says, give a Turing machine, give a Turing machine for language L, where L is equals to WCW and W belongs to 0 or 1 star, right? So if we say our W is equals to 0, 1, 1, our WCW can be very well represented as a 0, 1, 1, C, 0, 1, 1. Okay, so here we need to check for this as a W and this as another W, wherein this symbol should match with each other, right? First symbol should match with first, second symbol should match with second, third symbol should match with third, and so on. And this process should end when you get this separator, which is nothing but C. Okay, so how to proceed for that? Let's say our input contains the same thing, 0, 1, 1, C, 0, 1, 1. What we will do? First symbol 0, replace it with blank, because here and here we have blanks only. First symbol replaced with 0. And if first symbol after this C is also 0, in that case only we'll replace this 0 with some other symbol. So 1 skip, 1 again skip, C. On the receipt of C, we'll check is the symbol available after C is also the same symbol which we replaced with 0 earlier. If it is so, as it is visible here, yes, it is so. So we'll replace that symbol also with C and we'll move to left. While moving left, we'll encounter with this first C, skip as it is, skip as it is, skip as it is. On the receipt of blank, again turn the direction. And what we have on the tape now is this 1, 1, B, B. This is the current status of tape. What we'll do again, we'll repeat the same thing. First symbol, replace with blank. Skip this symbol, skip this symbol. Since it is also C, we're not interested in it. What we're interested in it is in the second input. Do we have first symbol in the second input same as that of what we have removed earlier? If yes, then we'll replace this 1 with C, because the earlier symbol was 1. So this is also 1. Replace it with it. This process will continue. Okay. So what we have is this available after this. Again, back 1 replace with blank. C skip. Since this is also 1, we'll replace it with C. Move to left. Now when we are coming back to this B, here we found that we are not getting any symbol which belonging to first input, because first input is already been replaced with blanks. So since C is available, it indicates your W is over. This W is over. When W is over, this your W should have been all symbol replaced by C. So we need to check that. C replaced with blank, C replaced with blank, replaced with blank, replaced with blank. And after this, we will get this blank. So what does it mean? Your second input, which was also W, has already been erased for the all symbols available in the first W, which means the pattern was of the type WCW. Okay. Is this clear with the logic? If yes, we'll go with the construction of Turing machine for this. Is this clear?
Yes, sir, it's clear.
Okay. So how to proceed further now? W belongs to 0 or 1 star. That means first involved in the first input may be either 0 or 1. Okay. So if it is 0, what we are going to do, that we need to show. Similarly, when it is 1, what we are going to do, that we need to show. So two different paths we need to follow. If it is 0, what we did, since it belonging to the first input and beyond it on the left hand side we have blank, with generalization we can replace it with blank to reduce our working area. Okay, so 0 replace with blank, move to right. Okay, the other symbols belonging to first W need to be skipped. So those symbols are nothing but 0, 1, 0, any, because W may contain 0 or 1, anything. So what we will do is 0 replace with 0, move to right. 1 replace with 1, move to right. This will continue till we don't get the separator, which is nothing but C. So on the receipt of C, replace C with C and move to right. After this C, we must have the symbol which we had replaced with blank in this phase, right? So after C, you must have 0 if string is of WCWR pattern. So if it is 0, in that case only we are replacing that 0 with C and movement to left, as I explained to you here, right? So 0 replaced with C and movement to left, because we no longer need to move further right, but we are looking for the first symbol from second input. That should match with the first symbol which we have already released from the first input. If it is so, move to left. Now here, Q3. What is needed is just traverse whole set of input symbols available. Move up to the leftmost blank. Once you receive blank, turn the direction and repeat the same process which you did in Q0. So what does it mean? 0 replace with 0, move to left. 1 replace with 1, move to left. Okay. And on the receipt of first blank on the left hand side, replace blank with blank and move to left. Move to right, not left. Because left movement is now we need to stop and we need to look for the first available symbol from first input. Here in this process, we have ensured that the first symbol was 0. Then what to do? Now we need to do the same process for if the first symbol from first input is 1, what process should be performed? Process would be same what we did for 0. Keep all the symbols, and if the first symbol from the second input is same as that of what was in the first input, in that case replace that with C. Same process we'll do here. Q3 was there, so Q4 and Q5, these two new states we'll add, and we'll repeat the same thing. 0 replace with 0, move to right. 1 replace with 1, move to right. C replace with C, move to right. Now, here we are talking about the C which was available earlier as a separator. What has happened in the previous pass was we have introduced this another C also, which will also come after this C. But this is nothing but another separator. We can treat it as a separator only because what we are looking for is the input from the second symbol, second set of symbols which we are representing as a W. So after this C, we will have those C in the earlier passes we received by replacing the input symbol. So those C's are also nothing but as good as separator for us. So just simply skip them. And if after this C, the symbol available is 1, we are assuming that the input was up to the mark as we are expecting, and will replace that 1 with C and move into left again. Same correction is needed here also, because if the next symbol is 0, again these C's we will get here also. C, C, R. And while going back again, after replacing 0 with C or 1 with C, we will come across these additional C's, which needed to be replaced with C and move to left. Now this process will continue till what? Till we are coming across this same, wherein when we are looking for a symbol from first input, whether it would be either 0 or 1, right? Either 0 or 1, in the place of them, that is W, we are getting this C, which will indicate that your first input is over. So when the first input is over, what does it mean? Your second input should have been already replaced with C. Okay. So you must not get any other symbol apart from C and blank on the tape. To ensure that, what we did on C, we're replacing that C with blank. Move to right, say Q6. In Q6, you must get only C's. C replaced with blank, move to right. Okay. And beyond it, you must have blank, which is indication of completion of the working area. So B replaced with B, movement to either right or left, it doesn't matter. And final state Q left. So this is the case for Turing machine for the language L, which is equals to WCW, where W belongs to 0 or 1. Is this clear with the process? Here we try to explain the logic. Here we constructed a Turing machine for it. Any queries on it? Utkarsha, Didi, am I audible?
Yes, sir.
Okay, ठीक है.